ideas yesterday, you're going to justify everything. So, given that the Fahrenheit Celsius conversion formula is Fahrenheit equals 9/5 times the Celsius temperature plus 32, can you find and justify each step to get the Celsius when it's 86 degrees Fahrenheit outside? Alright, so the whole goal today is to set up an equation, do the algebra, and justify every single step all the way down. So you're kind of making like a 2-column problem. Alright, what are we going to start with? What's the first thing I'm going to write down when I solve this problem, when I see that written in my book? Not yet. First, the formula. 9/5 times Celsius plus 32. What allows me to write that formula down?
Given.
It's the given information. You always start out with your given, for the most part. Now what would you do? If you're going to just solve this problem in algebra, what would you do next?
Plug in the cell.
Plug in the 86. Plug in. What's our property that lets us plug in? On that big list of properties yesterday? What lets us plug in? Substitution. So the high school word is substitution. We like to say plug it in. So, where am I plugging in the 86?
For C.
For F, it's Fahrenheit. That's got to go in place of F. So the 86 equals 9/5 Celsius plus 32. And we use substitution. That's our justification. Now it's simple algebra. What are you going to do next to solve for the C? Subtract 32 from both sides. What property is that? The subtraction property of equality. Now we actually do the subtracting. 86 minus 32 is 54. What did I just do here? What property? I simplified. Hey, how do we get rid of that 9/5?
Divide.
You can divide by 9/5, or what else can you do?
Multiply by 5/9.
Multiply by 5/9. If you multiply a fraction by its reciprocal, which is multiply by 5/9, multiply by 5/9. So what property was that? Multiplication. Property of equality. See what happens over here with your fractions? Know how you can remember how you can cancel? So when you multiply a fraction by its reciprocal, it comes down to 1. So that leaves you with just C. I put a 1 under here. How many times does 9 go into 54? 6. So the 9 reduces down to 1. The 54 goes to 6. I don't even need a calculator for this one. What is it? 30. So what did I just do here on both sides? I simplified. I actually did the multiplying. And we should end with C equals instead of 30 equals. What allows me to switch this around and say that C equals 30? The symmetric property. So, they give you a formula, you start with it as given, do some substitution, then algebra. Okay, let's throw a little geometry into the mix here. Let's do that. So example 3. This is a problem, so we're going to solve for x and justify each step. So here's our picture. Got a line, we're going to pick out a couple points on it, N, M, and O. The distance from N to M is 2x. The distance from M to O is 3x minus 9. And the distance from N to O is 4x minus 4. Okay, this is a problem right out of chapter 1, but we didn't do the justifying business. What you had to do was write an equation that relates these three pieces. So,
2x.
Noah, 2x.
Plus 3x minus 9 equals 4x minus 4.
Okay, perfect. So we added these two smaller pieces to make the big piece. Okay, that was not given to you. The only thing given to you was this picture. What you used to add those together, and you probably don't remember this name, it's called the segment addition postulate.
Oh.
Segment addition postulate. And if you look back in your notes, chapter 1, you would see that in there. But we're going to use this enough where you won't have to look back. So when I add the two smaller pieces together to equal a bigger piece, that's the segment addition postulate. Not given. All right, what would you do next? Simplify. What's simplify?
2x plus 3x.
Yeah, these two things are sitting together on the left-hand side. They find each other, and they make 5x. I still have a minus 9, and I haven't changed anything over here. But what we did was simplify, combine like terms. What's your next algebra step? I like moving x's first. It doesn't matter, you can move the 9, but I like moving x's first. I don't even know why. Must have been the way I was taught. How do I move the 4x? Subtract 4x. So what property did we just use? Subtraction property of equality. It's kind of easy, isn't it? Now we actually do that. That leaves us with 1x minus 9 equals, I got a negative 4 left here. Justify? That was simplifying. Next step.
Add 9.
Add 9 to both sides. Isolate the x. That's addition property. X equals 5. That was simplifying. So throwing in a little geometry. One more. Nope, they aren't. Can I get rid of this one? The next section's the challenge. What? Well, because this wasn't what was given. This was not, I was only given this picture. But we used the segment addition postulate to write this first line. See where here, this equation was given to me, so that's why I called it given. This equation was not given. You used what you learned in chapter 1 to write a new equation. And it was the segment addition postulate that let you do that. Okay. All right, let's get an angle going here. Okay, this bottom angle is going to be 6x minus 16 degrees. The top one is going to be 3x plus 5 degrees. And the two together are going to make 8x degrees. Again, solve for x and justify. Okay, so we're given the picture. We need to start with an equation. Who can write the equation for us that's going to relate those three pieces? Dean.
3x plus 5 plus 6x minus 16 equals 8x.
Perfect. So he took the two smaller angles and added them together, and he said it's going to equal. Okay. Okay, on that last example, when we added the segments together, that was segment addition postulate. What do you think is the postulate you used from chapter 1 that you forgot about? What did you just add together? Angle addition postulate. Angle addition postulate. So when you add two smaller angles together to create that bigger angle, it's the angle addition postulate. Alright, that's the tough part. Now it's just simple algebra. What's coming next? Simplifying. The 3x and the 6x are going to find each other and make how many? 9x. We've got a plus 5 and a minus 16 that find each other and make a negative 11. On the 8x we haven't touched. That was simplified. What's coming next? I like subtracting the 9x to bring the x's over to their side. That's subtraction property. So we've got negative 11 equals, what do we have over here? Negative 1x. Simplify. Are we done? What's next? Divide by negative 1 to get rid of that negative. That was division property. Now we've got 11 equals x by doing the simplifying. And finish it up with x equals 11 with symmetric. Okay, so most of the assignment today is solving and justifying. So if they give you the equation to start with, it's given. If you have to come up with something, then it's probably a postulate or a definition of something from before. Your assignment is written somewhere that I can't find right off the bat. Here it is. Page, what is it? Wednesday in Geometry, 108. 16 to 24 is even. Then the rest of these are all. 25 to 28. 30 to 34. 40 and 41. So just that first set of problems is even, everything else is all.